So we've built a simple chatbot that saves semantic memories to a user profile or a collection, and we've introduced trust calls as a way to update either schema. Now I want to pull these ideas together to build an agent with long-term memory. So our agent, which we introduced briefly at the start of this module, is called Task Maestro, and I actually use this to help me manage my own to-do list. So let's talk about some differences between this agent and the prior chatbots. The prior chatbots always reflected on the conversation saved to memories. Task Maestro will decide when to save memories. So that makes it an agent relative to a chatbot that always follows the same control flow. This has the ability to make decisions that dictate the control flow of the application. Now, also, the chatbots either save to a profile or a collection, depending on the variant we are working with. Task Maestro can save to multiple types of memory. It can save to a profile to collect user information. It can save to a collection of to-do items. So in addition to semantic memory, Task Maestro can also save procedural memory, which means it can save instructions about how to create to-do items that are provided by the user. So let's dig into the code here a little bit. First, we'll use Langsmith just like before. Now, I wanted to do something important before we dig into the agent itself. So we've been using trust call quite a bit. Trust call is a great way to create and update JSON schemas. Now, what if we want a little more visibility into the specific changes trust call is making? Like we talked about trust call using JSON patching, for example, to update a memory. But what if I want to know very precisely the patch that trust call added? You'll see this is very useful in our agent because we want our agent to be able to report back to us if an update is made. Here's this precise update I made to the memory. And for this, we need to dig a little bit into how we can get visibility into the updates that trust call makes. So this will be review for the most part at the start. I'm going to create a memory schema, and I'll have this list, which is a collection of memories. Cool, nothing new here. Now here's the only new thing. What I'm going to do below is I'm going to create a listener for the trust call extractor. Now this listener is something that LangChain provides. You can see this with listeners, and you pass in, for example, a class here that we're going to define. And I've provided some documentation here, but the key intuition is this. The trust call extractor is a LangChain runnable object, which means that we can add this listener and basically get the runs, which you can think of as like the steps in the execution of this extractor. We actually can fish them out and process them accordingly. In particular, we can get any time that trust call makes a tool call. Now we talked about trust call does all its JSON updating using tool calling under the hood. So this is a very nice, clean way to extract very precisely what trust call is actually doing. So all I need to do is create this class spy. This is all customizable. Initialize it. Initialize my model. Create the trust call extractor just like before, and I just add this with listeners spy to it. Now let's run trust call like before. I pass in some instruction, a conversation, and you see in this case I'm not using the listener stuff. This is just my trust call extractor. It's not this trust call extractor with listeners. This is just like what we had done before. I can see the tool calls here. That's all great. Responses, response metadata. Now let's update the conversation, and we'll go ahead and format any existing memories just like we did before. So there we go. Lance had a nice bike ride in San Francisco this morning. Cool. Now we're going to call our trust call extractor with this see all tool calls. Okay, so this is our trust call extractor with the listener on the end. So we run trust call, and now we're using our extractor that basically has the visibility into all tool calls made under the hood within trust call. Now you can see, if you look at the response metadata, you see two things. Basically, you see that the initial document that we passed, this doc.json ID 0, which is right here, you can see ID 0, was edited. And then we have also a new memory that's created. Okay, so that's what the response metadata tells us. Whenever it passes the JSON doc ID, it's indicating that it did make an edit to an existing memory. And we can see that these tool calls are parsed to the final responses. So that's great. But if we want to see under the hood all the edits that trust call made in order to produce this edited initial memory, That's where we basically use that spy.callTools. And this gives us very specifically, you see this patch.tool. This is a tool that's within TrustCall. So it's not something that we passed in externally. It's not one of our schemas. This is a tool that TrustCall has. And we can see it actually tells us the planned edits that it wants to make to that particular memory. This is going to be really useful in our agent because it gives visibility into what changes specifically TrustCall makes to any existing records or documents. And in our case, it's going to be to-dos. That's really all I want to show you here. Now, what's kind of nice is we can just write a simple little function to kind of format this in a nice way. We can call it on spy.callTools and the schema name, for example. And what this gives us is a really nice string that just says, here's what TrustCall did. It planned to update this document with these changes, and here's the added content. Cool. And then also it created a new memory. So this gives a nice kind of string representation of what we actually did to either create or update memories coming directly from TrustCall, which is really nice when we build our agent because it allows us to communicate to the agent, here's what TrustCall did under the hood. The agent then can respond back to the human with a sensible response based on these actual changes from TrustCall. So I just want to flag that before we get going. Now let's get to actually building our agent. I mentioned that Task Maestro is going to have access to 3 types of memories. One will be a profile for the user, one will be a collection of to-do items, one will be instructions about how to create to-do items, okay? So in order to enforce the agent to make a decision about one of these 3 memory types, what I'm going to do is a nice trick here. I'm going to create a memory tool, which is a type dict, that returns one of 3 memory types. So our agent is going to call this tool when it wants to update memory, and it's going to return to us one of these 3 options. This is a very nice little trick for enforcing a decision and a particular output schema from an agent. Now let's lay out the logic of the agent. So we've done very similar things in the past with our chatbots. We have first defined different types of schemas. In this case, we're going to define a schema for a user profile and a collection. In this case, user profile is going to have a few different fields. Now, this is entirely customizable, though. Name, location, job, connections, interests. And then our collection schema, in this case, is going to be a to-do list. So it's going to have tasked, time to complete, a deadline, solutions, and status. Now, here's what's nice. This is entirely customizable. You can modify these any way you want. These are just the particular memory schemas I personally like to use when I build this original agent for myself. And now let me show the flow of the agent before we talk through each node individually. So here's what's going to happen. I'm going to provide user input, and it's going to go to this Task Maestro node. Now this is kind of the core logical component of the agent, where we're going to have a model that has that memory tool bound, and it's going to make a decision based upon the input to do one of 4 things. 1, update the to-do list. 2, update instructions. 3, update profile. Or 4, just respond directly. And it's going to use tool calling to return a structured output that it routes to one of these 3 nodes. And if the tool call is not made, it just responds directly. It goes here to end. Now let's look at this Task Maestro node in detail. So here's the node, and you'll see this actually looks a lot like we worked with before. We pull in state, we pull into configuration, we pull in the store. Cool. We get the user ID. Now here you're going to see something kind of cool. We have a few different memory types, okay? But that's not a problem. They're all just namespaced in our store slightly differently. User ID profile, user ID to-dos, user ID instructions. No problem. For each type, we pull out the existing memories. Cool. And we just format them accordingly. So if there's memories present, we'll set that to the user profile. If there's to-dos present, format them. If instructions present, just pull them out. No problem. Now here's what's pretty nice. Take our model system message, format it with the profile, to-dos, and instructions we just pulled out from memory. Now let's look at this model system message. You can see it's defined up here. And you can look at all the text here in detail on your own, but here's the intuition. You're just going to say, look, here's the current user profile you have, here's the current to-do list, here are current instructions. You give it information about here's the types of long-term memory you're tracking, the profile, to-dos, and general instructions. Cool. Now here's where you instruct it about tool calling. You basically say, look at the interaction, decide whether you want to update your long-term memory, and if so, if it's personal information, call the update memory tool with user. If it's to-dos, call update memory with to-do. If it's general instructions, call update memory with instructions. That's really it. And this is just some simple instructions about what to communicate back to the user. Don't tell the user you updated the profile. Tell them if you updated the to-dos. Don't tell them if you updated instructions. So this is all customizable. That's what's cool about it. You can modify this prompt any way you want. This is how I like to do it. Error on the side of updating the list. Respond naturally to the user after the tool call was made. That's it. Pretty simple. So all we do, again, we bind our update memory tool to the model. We invoke it with our prompt as well as any messages that are in state. We respond. That's it. If we look at our flow here, when we respond, we can go a few different places, right? We can go to end, we can go to update to-dos, update instructions, update profile. Now, how's that done? That's done in this conditional edge here. So you can see we start, we go to Task Maestro, then we go from Task Maestro to route messages. That's a conditional edge here. Now we can even look at that right here. So all that's going to happen is it's very simple. We look at the last message from the model. Is it a tool call? If so, we just extract the argument. It's either user to do instructions based upon the type of memory that the agent decided wants to update, and we route to each node accordingly. That's it. Super simple. So let's look at those nodes. Go to update profile node. That's right here. So again, all we're doing here, get the user ID, get the namespace, get existing items from the store for profile, format the current profile, and we invoke the trust call profile extractor with our messages as well as the existing profile. We then save profile updates to the store. And this is one subtle but important point. We return a tool message to our agent indicating that its original tool call, noted here, to update the profile has been done. This is a very important thing. With tool calling, when a chat model makes a tool call, it expects a tool message back verifying that the tool call was actually performed. This is a very important point in kind of tool calling workflow communication. And when we build these agent graphs, it's very important to ensure that whenever our agent makes a tool call, we respond with a corresponding tool message saying, yes, that tool call was performed. Now that point also motivates what we talked about before with the SPY. So let's talk about our update to-dos. Now the profile is typically going to be a single document. You can modify it to make it multiple documents just by changing the trust call extractor if you want to. This profile extractor, you can basically add the flag to enable updates, but currently it's just going to be JSON patching a single profile. Now with to-dos, this is going to perform updates on a collection of to-do items. So the complexities increase a little bit. We talked about this with trust call already. The start of the flow is just like before. Get the user ID, namespace, existing items, and then format those existing items accordingly. This is effectively the same prompt as before. Now here's where it's a little bit different. We talked about our SPY. Let's define our SPY again, initialize it, and we're going to create our extractor here with a SPY as the listener. So you can see here we passed the tool to do. The tool name, again, as noted, is to do. And now we're enabling insertions, okay, into our to-do list. So what's going to happen is run our extractor just like before with the messages and the updated memories, existing memories, updated messages. Now save everything to the store, no problem. Here's where the trick comes in. Take that initial tool call that was made, and remember that method that the function we defined, extract tool info? call that with spy, call tools. This is going to basically dump all the information about what TrustCall did in terms of its patching / updating of memories or to-dos, or creation of new to-dos, into a nice tool update message that we pass back to our agent. This is the key point, and that's why I went to all the trouble to introduce this at the top, because when you provide the specific updates made by TrustCall back to the agent provides much nicer, more sane kind of feedback back to the human saying, okay, I've made these precise updates to these to-dos. So it really closes a loop in terms of what TrustCall is doing under the hood in memory management and updating, and then what the agent is communicating back to the user. That's the key point here. Now let's finally talk about update instructions. Remember, this is like the procedural memory, which is basically allowing the user to specify to the agent how it wants to save to-dos. So just like before, we'll get the user ID, we'll get the namespace, and we're basically going to get any existing instructions, okay, which is namespace, and then user instructions is the key here. Now we go ahead and pass those to our system prompt, formatted accordingly. We then invoke the model with the system prompt and the current chat history. We generate any new instructions. We then just save them back under that same key of user instructions. Okay, so it's namespace being instructions user ID, key being user instructions, and then accordingly just whatever the new instructions are. Again, we return tool callback, indicating that instructions have been updated. We already covered the router briefly. Now this kind of outlines the overall flow of Task Maestro. So let's see this in action a little bit. Again, I'm just going to pass a thread ID for short-term memory as well as my user ID for cross-thread or long-term memory. I pass in the input, my name is Lance, I live in SF with my wife, I have a 1-year-old daughter. Let's try this. Cool, nice and quick. We can see the tool calls are made to the user profile, profile's updated, and we don't return anything to the user about how we updated the profile. So that's it. Now I want to update a to-do. I say my wife asked me to book swim lessons for the baby, okay? Now you'll see the little bit of the magic of what we did here, okay? So it's going to call the to-do tool, which is exactly right. Now here's what's pretty cool. This tool message we talked about above quite a bit, this is what we are directly getting from TrustCall, okay? So in this case, we know precisely what TrustCall did, and we're annotating it as a new to-do is created. And then the model nicely responds to the user with what actually happened. I've added a new task to your to-do list. Cool. Now let's try updating instructions. So basically I'm going to give some instruction when creating or updating a to-do list, include specific or local businesses. Cool. So now the instructions tool is called, and the model responds kind of nicely. Now let's go ahead and search and see what I have in my memory. Cool. So for instructions, it basically has these updated instructions I just gave it, so that's fantastic. I can give it a new to-do, and this is pretty neat. So we get a very detailed overview of what TrustCall actually did under the hood. It created a new to-do, and it actually updated our prior to-do with some local businesses. That's pretty neat. Cool. Actually includes this Baleen La Petite Baleen Swim School, which is exactly the swim school that I've been looking into, so that's really nice. So that's pretty cool. It gives us kind of a nice response of what it added to our to-do list. Great. I can check the to-do list here in memory. I can see I have 2 tasks. Book the swim lessons, fix the door lock. And now I can interact with it and say, for swim lessons, I need to get that done by end of November. Now let's look at the trace and see what happened under the hood, just to reinforce this a little bit. So here I am at the trace. Here's my most recent input. And this gives me the whole kind of history and all the outputs and basically that final output. But let's walk through this step by step. So first, this was my input. Task Maestro received it. So here's the chat model call. We can see that it has this update memory tool bound. And this is really nice to note. In Langsmith, you can see when a tool is called by this called flag right here. So we know that this tool has been called based upon our user input. And we can scroll down and see that it was indeed called and it returns to do. So basically, the model looked at this input and said, yes, I want to update memory and I want to update my to-do list. Cool. So you can see then, it routed to update to-dos, that node. Let's open that up. And inside here is where we call trust call. Go down here to the chat OpenAI call within trust call. And we can see here, it calls our patch doc tool. So this is a tool that lives within trust call. We talked about it a little bit previously when we talked about using SPY to extract tool calls being made under the hood within trust call. It calls this patch doc tool, and we can see down here the planned edits to the existing to-do. Great. And we just see it decides to add a deadline. That's really it. So what's really nice is you can kind of work hand in hand with Langsmith to really see what's happening under the hood when you're running your to-do list application here. Now I can continue to interact with the app. I can add new to-dos. I can check my current memory. Now what's nice is I can create a new thread here. Okay, so it's kind of starting a new conversation, same user ID. And I can ask the app in an open-ended way. I have 30 minutes. What task can I get done? And cool. It gives me some suggestions based upon the estimated time to complete. And I can follow up with it and just chat. Cool. In this case, it responds directly. No tool calls being made. So this shows kind of in detail how I put together this agent. Now I'm back in Studio. Let me show you just some example further usage that I actually do with my Task Maestro app. If we open up the Memory tab, we can see default user. That's just me. Whenever I open up LangGraph Studio and I don't, in the configurable field, specify a user ID, it'll default to just default user for convenience. So this captures a bunch of to-dos for me. I can, in an open-ended way, ask it looks at my tasks. I can update these just in natural language. I can add new tasks. I can quit out of the app, come back to it at a later point in time. My memories are all saved locally. And I can basically ask, what do I have to do today or tomorrow? Let's say, is there anything I absolutely need to do tomorrow? And the agent can look at what's due, coming up, and give me kind of reasonable responses. This is just one example of a popular use case for application, managing to-dos, that is significantly enhanced by long-term memory, because I really want an agent that can remember things I need to do over long periods of time and help me track them with a nice natural language interface. That's really intuition here. Now, the key point is you can take this and modify it in any way you want. For example, you can change the schemas of the to-dos, of the user profile. You can also take these principles and use them to go build other kinds of memory-centric applications. So this to-do list app is just one of many things you can build that combines the power of kind of agents and long-term memory. But hopefully this was a good jumping off point to lay the foundations and help you go forward and have fun building memory-centric applications.